This video is going to talk more about our trig identities that we started discussing in the previous chapter. So before you continue, you may want to go back and review these identities, and that would be the reciprocal identities that we talked about before, also the quotient identities, the Pythagorean identities, as well as the cofunction identities, and then the even and odd identities. So we're going to be using all of these identities here to simplify expressions. So the first example that we want to look at is cotangent squared x minus cosecant squared x. And as soon as we see our trig functions being squared, we may want to think of one of our Pythagorean identities. And we happen to have one which is 1 plus cotangent squared x equals cosecant squared x. Now we want to come up with cotangent squared minus cosecant. So that means over here we need to subtract the cosecant squared from both sides, because then we would get cotangent squared minus cosecant. So if we do that, we would then have 1 plus cotangent squared x minus cosecant squared x equals 0. And then of course we need to move the 1 over, so we'll subtract the 1. So we would end up with cotangent squared x minus cosecant squared x equals a negative 1. So therefore, this whole expression then simplifies to a negative 1. All right, so the next example, we have cotangent x multiplied by secant x. And here, there's nothing squared, so we're not going to use a Pythagorean identity, but we may think about rewriting our trig functions in terms of sine and cosine. So if we look at the cotangent, we could use the quotient identity, which would be cosine x over the sine of x. And then for the secant, that's the reciprocal identity, so that would be 1 over the cosine of x. And then we can clearly see that we have a cosine on top, which will cancel the cosine on the bottom, and we're left with 1 over sine of x. Now, typically when you have this as a fraction, 1 over sine x, then we can simplify that using one of our reciprocal identities, and we know that 1 over sine is equal to the cosecant. And again, that's using the reciprocal identity. All right, next example, we have the cosine of x over cotangent x. And just like the previous example, we could actually change everything to sine and cosine. Or another approach is we could look at this and say, well, we have a cotangent, and we could think of this problem, if I split it apart, we could think of this as cosine x over 1 multiplied by 1 over cotangent x. And then if we look at 1 over cotangent, we could think of that as the reciprocal identity, which would then be the tangent. So this would be 1 over cotangent is equal to the tangent of x. So we could simply just write that as tangent over 1. And then we know that tangent we can rewrite in terms of sine and cosine. So that would be sine of x over the cosine of x. That's the quotient identity. And once again, here we have our cosine functions to cancel out, and we're simply left with the sine of x. All right, our next example, we have 2 cosecant x plus 2 multiplied by 2 cosecant x minus 2. So in this case, we have the parentheses here, so we want to actually multiply this. And we're going to multiply this similar to what we would do if we had something like, let's say, if we had, say, 2x plus 2 multiplied by, let's say, 2x minus 2. We would actually have to FOIL this out. So we would take 2x and 2x, and then 2 times 2x, and then 2 times 2. So if we apply the same concept over here, we're going to multiply here to get 2 times 2, or 2 cosecant, which would give us 4 cosecant squared x. And then we would multiply here to get negative 4 cosecant x. And then if we multiply with the 2 here, we're going to get a 2 times 2 cosecant, so that would be a positive 4 cosecant x. And then if we take 2 times a negative 2 would be a negative 4. And here, because we ended up noticing, hopefully you did, that we had the same expression except for this one was plus, this one is minus, and that's where these middle terms, then one is negative, one is positive, they're going to cancel out. So therefore we're left with 4 cosecant squared x minus 4. And one thing we notice here, this looks like a possible Pythagorean identity, except for we have this cosecant squared multiplied by 4, but we have a 4 cosecant squared minus 4, and if you get lost sometimes you can actually think of rewriting this as replacing the cosecant squared with a variable. So what would happen if you had 4x squared minus 4? What do we have in common? Well, we could factor out the 4 and you're left with 4 times x squared minus 1. So over here we can do the same thing. We can factor out a common factor of 4 and we'd be left with the cosecant squared x minus 1. And here we have this cosecant squared x minus 1. We would have a difference of squares, but now if we look closely at that, does the cosecant squared x minus 1 equal one of our Pythagorean identities? Okay, if we go up here and look with the Pythagorean identity, if we have 1 plus cotangent squared x is equal to cosecant squared x, then if we simply rearrange this by subtracting 1, because we need a cosecant squared minus 1, then over here we would end up with cotangent squared x equals cosecant squared x minus 1. So all of this is going to be equal to the cotangent squared x. So this would be 4 cotangent squared x. All right, we have one more final example for this section. What happens if we have 1 plus the tangent of x and we want to square the entire quantity? Well, if that's the case, then we're going to actually have to FOIL this. We need to write this down twice. 1 plus the tangent of x multiplied by 1 plus the tangent of x. Okay, so if you don't remember the shortcut for squaring a binomial, for example, if we had 1 plus x squared, if you remember the shortcut, you square the first term, you multiply the two terms together and double it, so that'd be 1x, and double that would become 2x, and then we square the last term, which would be x squared. So if you can't do that, then write it out and we can multiply it using the FOIL technique. So here then we would get 1 times 1, which is 1. And then if we multiply here, we get a tangent x, and then we get another tangent x. So 1 tangent x plus 1 tangent x would be 2 tangent x. And then tangent times tangent would be a positive tangent squared x. And you'll notice when I wrote this out, this is similar to the one over here, 1 plus 2x plus x squared. So if the trig function is causing you some problem to see what to do, replace that trig function like I did over here with a variable with this x and see what you would do. All right, can we simplify this any further? And this is where you're probably looking at this problem maybe and you're thinking, well, 1 plus 2 tangent x plus tangent squared is about as far as we can go. But if we were to look at the tangent squared x plus 1, do we have a Pythagorean identity that fits with this 1 plus tangent squared x? Well, if we go to our Pythagorean identities, we actually have 1 plus tangent squared x is equal to the secant squared x. So then all of this would cancel out and go to secant squared x plus 2 tangent of x. And that would be our final answer. So this would actually be, the 2 tangent is already here, so this would just be plus 2 tangent x. But the tangent squared in 1 is what's going to the secant squared.